inverse functions, and it's on pages 24 and 25. We are going to answer the question, how can I undo a function? So question number 125 says, a function machine is pictured at right. So here's our function machine over here. They're putting in a 3, out comes a 13. Okay? When 3 is put into the function machine, 13 comes out. When 4 is put in, 16 comes out. When negative 3 is put in, negative 5 comes out. Explain in words and write an algebraic equation for what the machine is doing to the number x that is input into it. Okay? So here's all your inputs in the left-hand column and your outputs in the right-hand column. They want us to figure out what is happening to x. That puts out the y. Okay? So if we take the x value and we multiply it by 3, then we add 4, we are going to get the y value. So 3 times 3 would be 9, plus 4 would be 13, 4 times 3 would be 12, plus 4 would be 16, negative 3 times 3 would be negative 9, plus 4 would be negative 5. So if we were asked to write it as a function, it would look like 3 times x plus 4. Any questions on part A? All right, for part B it says, Ambrose really wants to work for Functions of America. He is applying for a job in the recycling department. In this department, bless you, in this department, outputs are put into inverse function machines. The inverse functions will be written as f inverse of x. Fancy notation, it looks like the exponent is a negative 1. On does an output and recreates the original input so that it can be recycled and used again. For example, when a 13 is put into the inverse function machine below, a 3 comes out. So when they put 13 in, a 3 comes out. What number would come out if a 16 is put in? And what if a negative 5 is put in? So on your paper, you're going to write, if a 16 is put in, what number is going to come out? If negative 5 is put in, what number is going to come out? Hint, look at part A. Okay. Anybody know what the output will be if the 16 is put in? 4, right? You look up here. Here's the 16. So the output of the input becomes the input and the output. So if we put in a negative 5, what's going to come out? What will the output be? The negative 3. Okay? So you're basically just reversing or inversing the input and the output. All right, part C says, at his job interview, Ambrose needs to demonstrate that he understands the inverse function process. Explain in words what steps the inverse function machine is using to undo what the function machine did. Okay? So if we look back up at part A, a little bit bigger. The steps that we took were to multiply the input by 3 and then add 4. So we're actually going to go in the reverse direction and do the inverse operation. Okay? So addition and subtraction are inverse operations, they undo each other. And multiplication and division are inverse operations, and they undo each other. Okay? So if in part A, we were multiplying by 3, then in part C, we're going to divide by 3. And if in part A, we were adding 4, then in part C, we are going to subtract 4. Okay? But we also have to switch the order. So on A, the 3 came first. Here, it comes second. In part A, the 4 came second. So here, in part C, it comes first. So we have to do 2 switcheroos, okay? Change the order and do the inverse operation. So both of those things need to happen. Part D, write an equation for the inverse function machine, which is named f inverse of x. Note that the -1 is not a negative exponent. Definitely looks like a negative exponent. That's what you would write, but it's when you read it, you say inverse, all right? It is the mathematical symbol that indicates the inverse of the function of x. So if the function of x looks like that, then the inverse function of x looks like this, okay? So we're going to start with the x, we're going to subtract 4 from it, and then we're going to divide by 3, right? Notice how it looks compared to part A. Part A, we have a 3. You want to just double check. Here we have a 3. Here we're multiplying it. Here we're dividing it. Here we have a 4. Down here we have a 4. Up here we're adding it. Down here we're subtracting it. Okay, so you should be able to visually see the inverse operations of each other as well. Okay? So you should be able to do it in words like I did in part C, and then write it mathematically like it shows up in part D. Any questions on page 24? All right, flip over to the top of page 25. Top of page 25 is question 126. It says, Kimberly is also applying for a job at in the recycling department. Before the interview, she is given the function machine g of x at right and told that its steps are 1, multiply by 5, 2, subtract 8, and 3, divide by 2. Okay? So what does that look like mathematically? Mathematically, multiply by 5. You just write it right next to it. You put a little dot if you want to. You can even use parentheses to indicate multiplication. The easiest way is to just write it right next to it. Okay? Then to subtract 8, subtracting 8 always comes after whatever your term is. And then the last step, we do the division bar or fraction bar and divide by 2. Okay? Part A says, what equation should Kimberly write for g of x? A, right? Okay, so part A says, what equation should Kimberly write for g of x? Okay? We're going to do the 5x minus the 8 over the 2, right? And then, what is the output if 3 is the input? So we're going to take whatever number they give us and plug it in wherever we see x. We only have one x in this equation, but you might have one that has more than one x. Okay, so if you have more than one x, it goes in all the spots. Does that make sense? So we're going to plug a 3 in here. 5 times 3 is 15. 15 minus 8 is 7. 7 divided by 2 is 3.5. Everybody see how I got the 3.5? All right, for part B, it says Kimberly is asked for the steps of the inverse machine named inverse g of x and its equation. What should she write down? Okay, so we need to look back up here at these 3 steps and do 2 switcheroos, right? 2 switcheroos. One, switching the operation to its inverse operation, and the other switcheroo is to change the order, reverse the order, okay? So if they wanted us to multiply by 5, we're going to divide by 5. But instead of being the first step, now it's going to be step 3, okay? If the second step is to subtract 8, the inverse operation is to add 8. In the reversing of the order, because there's only 3 steps, it still ends up being step 2, because it's the backwards, and that's how it works out. If the third step is to divide by 2, the inverse operation is to multiply by 2. Let's cross that out and write multiply. Multiply by 2. Okay? So we want to multiply by 2, and because it was the last step, now it becomes the first step. Okay? Then they want us to write it algebraically. So algebraically, we're going to multiply our x by 2. We show that by writing it next to it. Then we're going to add 8 to that number, so we write plus 8. Then we divide the whole thing by 5. So we put our fraction bar, and we divide by 5. Okay? So for question number 127, in your team of 4, you're going to write the inverse function for each of the functions below. Verify that each inverse function is correct by checking several points in each function. What points are good for checking? Okay? So you have 2 of them.